Okay, hello everyone. Welcome to today's presentation sponsored by Seal Aftermarket Products. And this is my first webinar for this year, 2016. And glad to see you guys are all back.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and Acura transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments, please send your emails to webinars@atra.com. Any questions during the webinar, just go ahead and text them to me. I'll try to answer those best that I can. And then let's begin. We have, so you guys know, we have a lot of free training, especially with these webinars. You'll see this is the schedule here on the right. Now you notice there's showing 2 dates for every webinar, but we're trying something different this year. We're actually doing all the webinars on a single day rather than splitting them up. So the dates that you see here on the right just go by the first date. So obviously the next one would be March 1st, and that's going to be on the 6T40 internal. I know it's early, just letting you know this year we'll be at the Paris in Vegas, at the Paris Hotel doing the Expo in Vegas in 2016, and that'll be on October 27th through the 30th. Today we're going to talk a little bit about the AS68RC, the 6-speed Asian Seiki, or Psyche. I don't know if I've ever pronounced that right, and I probably say it 7 different ways. Now the Asian Seiki, or the TR80, is also referred to as the AS68RC by Chrysler, and it is manufactured in Japan. It's also called an AS6 because it's the 6-speed found in many 2007 and later medium-duty trucks, such as Dodge, Isuzu, NPR, Mitsubishi Fuso, and a few others. Today we're going to kind of talk about 2 different versions of it. So most of the information we're going to cover will be on the Isuzu and the Dodge. That's the Dodge 35, 45, and 5500s with the 6.7 diesel. Now these variations that we're showing you today are very similar to the functions and operations found in the Mitsubishi Fuso or any other vehicle. Now there's 3 driving clutches, 2 brake clutches, 1 sprag, 3 planetary gear sets, and it has a multi-disc lockup clutch converter. Now this converter can be applied in lockup anytime from 2nd gear on up. It has 4 linear solenoids, 4 on and off solenoids, 5 pressure switches to have a 1/8 thread, and 3 pressure switches with a 1/4 inch thread. It's also capable of adapting several different PTOs or power takeoff units. Now, when it comes to ordering parts, as you can see, this thing goes in several different types of vehicles. We want to make sure we have the right parts when we're ordering so we don't mismatch anything during rebuild. You can see here that the ID tag is just below the PTO cover here on the right, but there's also some stickers with the ID numbers right on the cover, just above the cover, and again on the bell housing on the left side. The AS obviously is for Eisen or AS68RC. The 6 is for 6 forward speeds. Torque capacity is 8, and that's going from 0 to 9, 9 being the highest. The R is rear wheel drive, and then obviously it's a commercial application. Now this unit can come in 2-wheel or 4-wheel drive, and they all have tow haul mode. Now the serial number is going to identify the year. For example, this is a Ford J0192. So the 4 is for the year 2004, and J is the actual month of October. And again, the serial number is the last 4 digits. That's going to be the important part when it comes to order the parts for this. Here's a cutaway view of the unit, and there's some confusion here that you may run into. Notice that I have all the clutch packs being shown in the cutaway view from 1 through 6. Now 1 is the K2 driving clutch, but sometimes the factory refers to that as the C1 clutch. Even though it's the K2, they call it the C1 because the K1 driving clutch, just below it, is actually the CO clutch, and then so on and so forth, and you can see that in this chart. Now this is the internal component apply chart. I really like this chart because they show you the elements that are being driven, what clutches are driving in what gear. They're giving you the basic ratios found in this transmission. Also gives you the holding clutch and what element is being held. So this is good information if you're chasing a noise that changes during a shift and only appears on one shift, or maybe changes the volume of the noise as it goes through different shifts. So this will kind of help you out with that. Now this is the cutaway view for the rest of the internal components. You can see that we have the P1, P2, and P3 planet, and then the sun gear shaft or the intermediate shaft. Let's talk about the speed sensors. We have 2 speed sensors. There's going to be 1 input or turbine speed sensor and 1 output. Now both of these speed sensors are 2-wire Hall effect. They share a common 8-volt supply from the TCM, so they generate a DC square wave signal. Now the input speed sensor measures the speed of the sun gear of the P1 planet. That's because the sun gear and the PTO drive gear are one assembly. So you'll find it either right above the PTO gear or right above that area or on the side, depending on the vehicle. So this monitors the PTO drive gear teeth. It uses that as an exciter wheel. It'll pulse about 69 pulses per revolution. Now the TCM uses this information to monitor the torque converter clutch apply and slip. It also uses the input speed to regulate the torque converter clutch pressure. The TCM also uses this signal along with the output speed signal to determine gear ratio and slip. Now, as I mentioned before, the turbine speed sensor can be found on the top center of the case on the Isuzu models, and mostly found on the right-hand middle side of the case on Dodge vehicles. Now, the output speed sensor, that's located on the driver's side of the extension housing, and it monitors the speed of the parking gear. Now, this will have about 16 pulses per revolution. Now, this signal is sent to the TCM to determine vehicle speed. Now the ABS system compares the output signal to vehicle speed to verify the actual vehicle speed. If the sensor were to fail, the ABS system provides a vehicle speed as a backup. Now the TCM, again like before, it also uses it along with the input speed signal to determine gear ratio and slip. And here's where they're located. As you can see here on the left side, the Sensor on the top would be for Isuzu, and right about there in the middle you would find it on the Dodge vehicles on the right-hand side. And the output speed sensor is usually found right there on the two-wheel drive on both units. So we give you the pin ID for the range sensor. So if you want to actually do a continuity pin check, we're showing you that chart there on the left. Obviously pins 10 and 6 are for the starting system. If you wanted to check the signal with a meter, basically just ground your meter at the battery, and then you would back probe each one of those pins as you moved it through the gears. Located on the driver's side of the transmission. We've had quite a few problems with these range sensors also. Now let's talk a little bit about the solenoid function. As I mentioned before, we have 3 normally vented and 1 normally applied linear pulse width modulated solenoids, and then we have the 4 on and off type. Now the 3 normally vented are the solenoids A, C, and D. The A solenoid controls clutch pressure to the B1, K1, and K2 clutches. Solenoid C controls pressure for forward and reverse engagements, as well as the torque converter clutch apply. Solenoid D controls main line pressure. Now the 1 normally applied solenoid, which is solenoid B, that controls the pressure to the B2 and K3 clutches. Now the snout on this solenoid is smaller in diameter than the other 3, and it requires a smaller sized O-ring, which is identified by a different color than the others when you find the O-rings in the kits. Now the 4 on and off solenoids, 1 through 4, are normally closed, and they operate in conjunction with the linear PWM solenoids to control the shifts based on road conditions, and I'll show you that in just a moment. Basically what the solenoid looks like, as you can see, A, C, and D are normally vented. The width of the solenoid is a little bit different than the other single solenoid, solenoid B, the normally applied one. All the on-off solenoids 1 through 4, they're all basically the same. They don't require an O-ring. The snout size is the same on all of those. And you also have the resistance there for those solenoids. And here's your solenoid locations. We give you the resistance for each solenoid, as well as identifying the location for each one. Now we're showing you some wire colors here. These are probably the most common colors you'll see as far as the connectors going to the solenoids. As you can see, all the solenoid connectors are basically the same color, so the wire color is going to be a big help. Again, this can vary from a different year and model, so try to be careful to possibly use your cell phone, take a snapshot picture of the valve body before you start disconnecting the solenoids. And this is your solenoid apply chart. As you can see on the right, we have all the linear solenoids, whether they're producing high or low pressure at the time of the shift. And you'll notice here, like in drive 1, the on-off solenoids, we have 2 that are off, 2 that are on. They stay the same way during the shift, and then you'll see them all go off once the shift into second gear is complete. Now on the 2-3, on the way to the 2-3 shift, you'll see 1 come back on. Then once it's in third, that one will turn off and another one will turn on. So you can see these are controlling, help controlling the shifts along with the PWM solenoids. And we give you the case harness connector pin IDs. So if you want to do a pin check for resistance, or if you want to monitor the amperage to the solenoids or the voltage, you have all the pin IDs here for you, because there are 2 case connectors for all the solenoids and switches inside. Now there are the 8 normally open pressure switches located on the valve body. Now these pressure switches are known to go bad. Now they'll close under a certain pressure. The TCM uses that switch signal to monitor the hydraulic circuits. This also to verify if the shift valve actually operated correctly. Now there's 3 switches that have the 1/4-inch pipe thread and 5 that have the 1/8. Both of these switches close at different pressures. You have the part numbers right there in your handout for you. Now, during assembly, the connectors get mixed up, so use the information we're going to show you in the following parts of the webinar to know where they hook up. Again, like I said before, it's always a good idea to take a snapshot, either with a small camera or with your cell phone. And here's where they're located. You can see the 3 that are 1/4 inch are in the blue circles, and the rest that are in the 1/8 pipe thread are in the red circles. Again, wire colors may vary, so be careful when we disassemble. Now, I mentioned before that these do go bad quite often. We've actually seen them brand new out of the box, bought right from the dealer, and not work correctly. What it'll do to you is you'll get a code for that switch, buy a new one, put it on, and it still doesn't work right, and you'll think now you have a wiring problem and spend a lot of time diagnosing something electrical when the whole problem is just the switch not closing. It would be a good idea at this point just to see if the switch is working correctly, and obviously you can test it on the bench. Now, what happens with these ones that come right out of the box is sometimes they just need to be kind of like loosened up. So we take some unregulated shop air. We're just going to click it a couple of times with that. We're not sitting here with the air pressure trying to blow the switch up. We just want to kind of loosen it up. Because as you can see here, if we put a multimeter on it and we add pressure to it, we can see that they're normally open, so they're going to close with air or pressure. So it should go from OL to 0 once the switch closes. Now the 3/4 inch close at about 65 to 70 psi, and then the 5/8 inch actually close at about 45 to 50. So if you regulate your air gun like I was showing you here, you can see I've got it set to between 40 to 50 psi to see if I can get it to work. So if it was a brand new switch and it's a 1/8, I'm going to try 45 to 50, see if I can get the switch to open and close with the meter. If not, I'm going to regulate my pressure up higher till I get it to work, and then just keep checking it to make sure that it is going to work at the correct pressure. Like I said before, we have the multimeter. We grounded at the battery. You can go ahead and check the voltage to the switches, and you have the chart there on the right, so you can actually monitor what the switches are doing with the multimeter to see if they are actually working or not. Now there's 2 temp sensors. There's one for the sump. They're both a thermistor type. Obviously, the higher the temp, lower resistance. One is located on the valve body underneath the solenoid brackets. You can't really see it till you lift up that bracket. Now the TCM measures that oil temperature in the sump that's actually cooler than the converter oil. This is to control shift strategy based on whether the temperature is high, low, or normal. Some vehicles you may find the temp sensor right there on the cooling line, and that would be on the top cooling line fitting. Same type of sensor. As you can see, ours got busted up on the case that we got. And the TCM going to monitor this fluid temperature for the converter, and this is obviously hotter than the oil that's in the sump, and it's looking to control the lockup strategy using this information. Let's talk a little bit about power flow. This is where those extra letters come in. As you can see, the K1 clutch is the CO. The K2 clutch is the C1, is our CO, and so forth throughout the rest of the unit. Then we have our 3 planetaries. So if we're chasing a noise, this is a good time to use these charts to see if we kind of figure out what's going on with it. So if we have it in reverse, you can see this ring gear is being held. The planet's being held because of the low reverse clutch being on. There's your ratio in reverse, and all 3 planets are actually working. Now when we get to first gear, we put it in drive. You can see again the low reverse clutch is on, so the ring gear is not going to move, but the planet is working. K1 clutch is on, and just the sprag is on. We go to second gear, the brake 1 clutch comes on. Now we have 2 planetaries working. K1 is still on. K1 still on here. We have the K3 clutch on. This is power flow in third gear. All three planets are working. So if we've got a noisy transmission at this point only and we go to fourth, everything's kind of a one-to-one here. So if the noise goes away, it's going to be kind of tough to determine which planetary is doing it. And then in fifth gear, we have the K2 clutch on. Notice the K1 is not on anymore. Now we're overdriven. And then for sixth gear, K1 and the B1 clutch are on. We have one planetary really not doing anything, not under any load. And this is our last overdriven ratio. Fail-safe. Only gears available in limp mode will be fifth gear, third gear, or reverse. Now obviously if the fault occurs during the time that the transmission is in fourth, fifth, or sixth, the TCM will remain in that higher gear until the conditions are safe enough to downshift to third. Now obviously if we're going 70 miles an hour down the road, we wouldn't want fail-safe to dump us back into third till we were going slow enough. So if the fault occurs in first, second, or third gear, we'll remain in third and there'll be no upshifts higher than that point. Reverse is always available in any default range. The mill light will come on, line pressure will be commanded to maximum, and at this point we should have some trouble codes stored in memory. Now obviously if we're in fail-safe and we shift from park to reverse or to drive, all of our garage shifts are going to be extremely harsh. I've given you a list of the PO codes, the generic PO codes, if you have a scan tool software that's capable of working with these vehicles. Or on some of the Isuzus, they have a flash code that you can get manually, and I'll show you that in a moment. So you can see that it's quite a long list here, all the way to even communication codes at the bottom. Again, we have the two-digit flash codes listed with that. Also in here we have the relearn procedure. Now the relearn procedure in Dodge vehicles is performed through the Chrysler DRB or capable scan tool or software. Now the NPR vehicles, you can do it manually without a scan tool. Now what's really important here is you've got to perform the relearn after any major work's been done, and you have to follow these steps in order. Vehicle must remain stopped, transmission temperature has to be between 104 and 194, and if you skip any steps, the AT over temp light will blink and you'll have to turn the ignition off and start the relearn all over again. So we give you a list of things that has to be done. Make sure all the accessories, headlights, everything's turned off. Parking brake is set, fluid level is correct, add some if you need to. Make sure the transmission temperature is right, start the vehicle up, move the shifter from neutral to drive 5 times. Now what you can do here is you take a jumper wire, go from pin 4 to pin 11 on the DLC. The trans check light should start blinking. 1 second and off for every 2 seconds. Apply the brake pedal with your left foot. Now you must keep the brake pedal applied for the rest of the procedure. Verify the engine is at idle. The overdrive switch is pressed in. That would be overdrive enabled. Now move the shifter from drive to manual 2 3 times. Make sure the check trans light flashes on and off every 0.4 seconds. Now we're going to turn or disable the overdrive. Then we're going to check, verify that the trans light is blinking. And as you can see, this is quite a few steps, so we have to be careful that we follow this correctly, or we're not going to be able to do the relearn, and you won't be able to get the codes out of it. So as you can see here, just keep going through this step by step. Obviously, when the check trans light starts to blink, we increase the engine RPM to 1,000 to 1,500. We enable the overdrive again. Now the check trans light should start to blink slowly. Wait till the light goes out. Don't let the engine RPM change. That's the step 2 learning. Move the shifter to reverse. Disable overdrive again. Make sure the check trans light starts to blink again. That's step 3. When the light blinks quickly, increase the engine RPM again. Are we having fun yet? All right. Enable overdrive. Wait till the trans light starts to blink slowly, and then you can go ahead and look at the patterns from that point. Place it in park, release the brake, disconnect your jumper wire, turn it off and on again. Make sure no warning lights come back on, and you should be done with the relearn procedure. Again, turn it off, turn it on again. If no warning lights come on, you should be all done. Should only take about 5 minutes, right? Pump issues. This is probably the #1 call we're getting on the tech line lately with this vehicle. Spun pump bushing, or the pump gears are welded to the stator support. Just massive damage in that area. This happens quite often on this transmission, and many like it. We're seeing it a lot on the 5R110s. The earlier Aiden Seiki, the 450-43 LEs, for example, we got many calls on those. There's been articles and bulletins written on the Mercedes having this problem, the 7229. So I've come up with this list that would basically work on just about any vehicle that has this problem, and especially like right after rebuild. The thing's installed, it's sitting on the lift, we're filling it up, starts pouring out the front, and obviously we've spun the bushing and we've wiped out the pump. May have come in that way, replaced the pump, again on the lift, within a few minutes doing the same thing. So here's a few tips. Converter pilot, no matter where your converter comes from, whether it's new or aftermarket. You want to make sure that it has a good fit in the crankshaft. Make sure it doesn't have any paint on it. Sand the paint off the pilot. It's not going to void the warranty on your converter, just removing the paint off the pilot. Make sure the journal that it fits into is smooth. It's free of any burrs or nicks. What we used to do in the old days, back in the 350 days, we were always told to check the journal, and if it was worn out on one side more than the other, then turn the flywheel so that the worn side was up, so that when we put our new converter in, it rested and stayed centered on a good portion of the actual the bore for the crankshaft. Check the crankshaft, make sure that's clean, no corrosion in there. Make sure the pilot doesn't burn. Take some extra time, put the converter up to it. I know some of these converters are pretty heavy, but it's better to check it now than to have it just spilling fluid out the front during a fill-up, or even after a short road test. Make sure when you bolt up the converter's pulled towards the flywheel first. I've seen so many installers do that. They'll start one bolt and just nail it because it's in the smaller alignment hole, and they've actually cocked the converter. It happens many, many times. Clean the engine block and the bell housing. Make sure if the unit's painted, take the paint off the edge of the bell housing where it mates up to the case. Look at your dowel pins. Are they extended out far enough? Are the dowel pin holes in the bell housing? Make sure they're not worn out. These are all things that should be looked at on just about any vehicle anyways. You may want to add a ground strap from the engine block to the battery to prevent electrolysis. You can add some guys don't like to, but in our shop we used to add a ground strap all the time from the bell housing, not the tail housing or anywhere else, right from the bell housing to the frame. When you're putting the pump together, I always squirt a little bit of oil in my pump. Some guys I know like to put a little bit of trans gel in there. Kind of helps the pump on initial startup to have like a vacuum and pull that oil in quick. Now here's a couple of tips that we used to use on the earlier A's and ones that were failing right on the lift. And again, like I mentioned before with the 5R110s, we're also starting to get a lot of calls lately on the Torque Shift 6, the Ford 6R140. Now with the engine off, most people put in like 4 quarts, then they'll start it up, and that's where the problem happens. The installer gets in, starts up the truck, gets out, lights a cigarette, starts talking to the other installer, then he starts to add the next 4 quarts. I mean, a lot of shops like to use gallon jugs, and they're doing it that way. It's already too late. Within 10 to 15 seconds, that sump is empty. That pan is dry. Now the pump's running dry. This is usually what ends up causing the failure in the first place. If you've ever seen these early A's and safeties, man, they fill up so slow. So why not just, have another one ready as soon as you start it up? But even then it might be too slow. So instead of just putting in 4 quarts, put in 8, or put in 4 and start it up. Wait 10 seconds, shut it off, add 4 more, start it up again. Shut it off, add 4 more. Then start it up and start checking the fluid level. As long as we've got a lot of oil in that sump, that bushing and the pump is not going to run dry. Here's a big mistake that I've seen quite often, and you would think to yourself, how could this happen, until it actually happens to you. The shift indicator on all the boxes that go around the gears, it'll actually, instead of the box going around each individual spindle gear, it'll actually go around all of them. It'll set a code 706, which is range sensor rationality. You might even get a code 2806, which says trans range sensor alignment. The problem here is the solenoid connector. There's 2 solenoid connectors you can see here on the right, because there's 2 case connectors going into the case. One of them is the same pin configuration as the range sensor, and they're pretty close together. And you'd be surprised. I know some guys are probably thinking, well, the harness won't allow me to. Well, believe me, I wish that was true, because I can't tell you how many times I've dealt with this problem on the tech line. Basically, they swap the 2. We end up with this problem, and then all we have to do is basically shut the vehicle off, clear the code, swap our connectors back, and we're ready to go. Now here's another code, P0707 or 2806, and the thing that sets these codes, if it detects that the shift lever or anything like that is out of sync for 2 seconds and 2 consecutive key cycles. And then we give you the rest of the reasons that can cause it. Obviously, if it doesn't read correctly, never detects neutral more than 4 times, or it doesn't detect reverse for more than 4 times at 500 milliseconds. And then obviously the code 2806, saying that the shift lever is not aligned correctly. It just notices that all the shift selections are reading open for more than 2 seconds. Very common. These switches fail all the time. I'm sure they're not cheap. What we used to do on the old, with the 4L30Es that were coming in on the Isuzu Troopers, that switch was like 180 bucks. We would actually go in on those and just grind these little rivets off and split the sensor open, and find that all the dielectrical grease that's in there just gets rock hard and gummy, and switch doesn't work right. We were cleaning those out, tapping the holes, putting some new grease in them, and screwing them back together. It's just something to think about. K3 clutch burnout happens quite often on this transmission. Most of the time the reason is because the solenoid itself has failed. There's the linear solenoid B that we're showing you here on the right. Now if you have an 06 and earlier Allison solenoid, you can use the trim solenoid A to replace the damaged one. Now Allison's trim solenoid, the A and B, are both different size snouts. So if the A solenoid fits this one, then the B solenoid will fit the others. And again, as long as it's 2006 and earlier. Now the reason I'm telling you this is because Allison trim solenoids, whether it's A or B, are about 120 bucks a piece. All you have to remember is put the small snout with the small snout of the one you're replacing, and vice versa. Now this same solenoids for this AS68RC, the linear solenoids, come from Dodge with the valve body only for like 3,500 bucks. So you can save yourself a lot of money here. Now the pressure switches and the on and off solenoids, they all sell for about $200, and they are sold separately. Now the flow rate, resistance, everything works the same, and we've had no problems using the Allison solenoids for the trim solenoids in place of the linear solenoids. Here we have a code 796. Now this is saying that there's a problem with the pressure control solenoid C, or linear solenoid 3, same thing. Now what's happening here is the TCM verifies the operation of the control valve 3 by monitoring the pressure switch number 7, almost like a 604. If it tells the solenoid to do something, the switch doesn't close, it says, hey, must be something wrong with the solenoid, and sets a code for it, a performance code for it. It's not electrical. Obviously, the transmission goes into limp. You'll have no lockup, and based on the current gear and conditions, that's what gear the fifth or third is where it's going to be locked in at. The three most common things that cause this code, obviously, if the switch is closed for more than 160 milliseconds. After the transition of the control valve 3 goes from off to on 3 times. Now, there's no electrical fault been detected by the computer for the solenoid, so that's why it stays as a performance code, and that's established in 10 seconds. Second thing, open for the control valve at maximum command pressure. The electrical fault of the solenoid, again, not detected for 10 seconds. And then the third thing is basically almost like the first one, except it's not looking at that on and off command of the solenoid 3 times. Now, like I said before, we can hook up our meter, go in there and check and see if the switch is opening or closing. But the bottom line comes to this, just like with any other transmission using pressure switches, again, like any Dodge that we've dealt with in the past, or any other transmission, 4L60E uses pressure switch manifold. What else could cause the pressure switch not to close? What if there's a leak in the circuit? That would also keep the switch from closing, wouldn't it? Solenoid's not electrically being setting any faults. It's working correctly. Could be. The valve's not sticking. The switch test's okay. And this is one of the things that we run into. Take a look at these sealing rings up here on the right. They're too small for the shaft. Now, this was an 09 or later vehicle, and I found out that there's 2 different lengths on the shaft, and there's also 2 different diameters. Obviously, that's going to change the diameter of the stator support also, and the length of it. I don't have all the measurements right now handy, but keep in mind, obviously, if you're changing the drum, I always eyeball and measure everything. I'll put the 2 side by side, I'll look at the length of the shaft and the thickness, and I'll obviously find that there is a difference if they sent me the wrong one. But irregardless of that, if the kit only comes with one size set of rings, I know a lot of guys like to grease up the ring grooves and then put their rings in. You may not catch this. I always like to check my rings on the groove, and I've always bore fitted my rings in the stator support on any transmission I've worked on. I want to make sure I'm getting the right parts because I don't want to have to pull this thing back out. So be aware of it. Keep an eye out for it. Anything 09 and later may or may not have the longer and larger shaft. Here's some pressure specs for you and tap locations. We have them all here on the driver's side, and we've also included all the ones on the right. Whether it's cooler flow, clutch pressure. The K1 clutch that you see down here, it's fairly tough to see. It's in between the 2 fittings. It's right located right there. I wish I had a better shot of that for you. Then there's your pressure specs. Obviously, this is a transmission that works on high line pressure like Allison. You may see a dip in pressure when it's being engaged. And the same thing as you're going down the road, you may see it drop quite a few pounds before it makes the shift and then go back up. Service information, according to the factory, should be every 30,000 miles. Change the filter only if the oil is contaminated. I don't think I would do that. I think I would change it along with the fluid. We give you the part number for that. And then you have the chart on the right that tells you how to check the oil. Obviously, we're looking at a certain temperature, and that's what we want to make sure that the fluid is correct at that temperature. I prefer to use OE fluid. It's something we suggest, and you can see here you can buy it in 1-gallon jugs. A little tidbit here, the Isuzu is easy to identify. The filler tube comes out of the pan. If this was a Dodge vehicle, the filler tube would be coming out of the case right about at the end of where that arrow is. And when we were talking earlier about the 8 being the torque capacity, we now have an AS69RC. This came out somewhere in 2013 or 2014. And you can see there was a difference in the gear ratio change. PTO could be used from either side. And one of the major things they've done is take all the accumulators out of the case and actually put them into the valve body. And we have all those identified for you. Notice here that all the solenoids went to a linear type, no on and offs. And there was some changes in the check ball and small part locations and functions, so we have that information in this handout for you. Obviously, it's a bigger transmission. I know that the AS68 is pretty big. This one here, the parts are much larger. The components, you're not going to be mixing these up with the 68 for sure. Another thing they've done is they've taken the input speed sensor and put it inside the trans underneath the valve body. And another cool thing that I thought was pretty good, because Sprague's always failing on the AS68 on the earlier 450/43 LE. The F1 rollers used to fail quickly on a lot of these vehicles. They've actually eliminated it. Now on the earlier 68, the B2 clutch is splined to the F1 roller and provided engine braking and manual low. Now on the AS69, the B2 clutch stays on throughout first gear, where on the others they'll dump that low reverse clutch at about 5-6 miles an hour and expect the Sprague to hold. They've just done away with the Sprague and just using the clutch for engine braking. So in drive or in manual 1, you'll have that engine braking without the use of the Sprague. That about does it for today's presentation. I want to thank you guys for attending. I really appreciate your time, and I hope I see you at the next one on March 1st. If you have any questions at this time, just click on the little hand icon by your name, and I'll be glad to help you out.